Hello, myself, Mohammed Irfas, and my teammates are Boina Hassan and Abdul Rakeen from the Automation and Robotics, Department of Electronics and Instrumentation. Today, we're excited to present our project, the Mini Travel Refrigerator for the Process Control Lab. Components. Our project uses the following components: a Peltier cooler, a cooling fan, a W1209 digital temperature controller thermostat module, and a limit switch. Working process. Our mini refrigerator is designed around the Peltier cooler, which creates a temperature difference by transferring heat from one side to the other when powered by a 12-volt DC supply. The hot side of the Peltier module is attached to a heat sink and a cooling fan. This setup helps dissipate the heat efficiently, allowing the cold side to stay effective for cooling. Inside the refrigerator, a temperature sensor constantly monitors the internal temperature. This sensor sends data to a microcontroller, like an Arduino, which processes the information and controls the system. If the temperature inside the fridge rises above a set threshold, the microcontroller triggers a relay to power the Peltier module. Once the desired cooling temperature is achieved, the Peltier module is turned off to conserve energy. To improve efficiency, we've included safety features like thermal cutoffs and PWM, pulse width modulation control. Additionally, proper insulation helps maintain low energy consumption, ensuring efficient, long-term cooling performance in this compact fridge design. Conclusion. In summary, this mini travel refrigerator project showcases our skills in process control and temperature regulation, providing a practical and portable cooling solution for lab use.